This video is produced by the UCD Math Support Centre in conjunction with the UCD Access Centre. In this video we will be looking at how to use sequences in the financial math section to figure out savings. So let's look at case 1, which in previous videos we will have seen about putting money into a bank and leaving it there and just letting it appreciate or gain interest over time. So suppose we put P euro into a bank account T months or years ago, and each month or year or week or wherever interest is measured, this money was collecting K% interest. Then using the compound interest formula, this payment is now worth P times 1 plus I to the power of T euro, where I is equal to K over 100, where I is the decimal form of the percentage. So that's all well and good if we have our lump sum of money, put it into a bank and just leave it there. But often when we're accumulating money by saving, we will be putting in the same amount of money, say every week, every month or every year, instead of just putting all of our money in at once. So let's see what happens if we put P euro into this bank account every month or year for T months or years. We want to know how much is in the account now. So we can do this by calculating what each individual payment is worth now and adding up. So let's assume we just made a payment. Working backwards through time, we want to find P plus P times 1 plus I to the power of 1 plus P times 1 plus I squared plus and so on, all the way up to P times 1 plus I all to the power of T. Notice that this list above actually forms a geometric sequence. So, using the geometric sequence formula, which we discussed in a previous video, we see that the sum of the first n terms of a geometric sequence is given in the log tables as S sub n is equal to A times 1 minus r to the n all over 1 minus r. So how would we apply that to our question? Well, we identify A as P. It was the first term in this list. We see P here. We then need to recognize what our common ratio is. We can see that the difference between each term is we have multiplied by 1 plus I. And we can count simply that the number of terms is T, which is the number of years or the number of months or so on that has gone by. So now that we've identified what A, N, and R are in our case, we can see that the total is equal to P times 1 minus our R value in here, 1 plus I, to the power of our N, which is T, all over 1 minus 1 plus I, which gives us the general formula, P multiplied by 1 plus I to the power of T minus 1, all over I.